Thanks a lot.
Hello everyone, and thank you for being here. My name is Vasiliki Kourgiozou and I'm an energy specialist at Hodgkinson Consultancy. This is my case study about Kidbrook Village here in London and the 5 residential blocks you can see on this image. And as we all know, corridor overheating can be an issue when heat gains are not properly mitigated. However, in this case, passive evaporative cooling was intended for the day-to-day ventilation along with smoke control. Such capabilities are not standard within the dynamic thermal simulation software, and therefore I use detailed HVAC within Design Builder and the environmental management system scripting tool to be able to represent the passive system accurately. The model was built in the fabric specification and the M&E design. And then you can see on the diagram here the airflow path and the system components with the evaporative cooling fan on the roof, which pre-cools the incoming air, the hotter air, by a water-wetted pad by evaporating some of that water. And then the cooler air is distributed in the corridors and then extracted through the ceiling void and the staircase from the roof-mounted fan. To the left you can see the model on the HVAC interface with the evaporative cooling and the fan on the supply side, the demand side control zone, and then the retail plenum for the ceiling void. The set point manager on the top shows is where the system controls were set up for the fans to run when internal temperatures are higher than 21 degrees and the evaporative coil to run when external temperature is higher than 18 degrees. There was also a second layer of environmental controls through the EMS scripting tool of Design Builder, and the script you can see on the right that I developed to modulate the fan speeds when external temperatures are lower, and then therefore you need less air to make it energy efficient and avoid overcooling. In terms of results, the simulation showed compliance with the CIBSE TM59 criteria, and you can see the temperature distribution graph, which shows temperatures are maintained between 20 and 26 degrees. Never exceed the 28 degree threshold. Also, the simulation results you can see here in green were compared against a monitoring post-occupancy evaluation study for the same scheme, and you can see that both show comfortable ranges achieved for the spaces type, and also match each other quite closely, considering the model was not calibrated to the external data, the monitored ones, and the features of the monitoring exercise. The last graph here shows a comparison of the evaporative cooling system and summer internal temperatures in green with a mechanical fan supplying the same amount of air changes within the corridors. And the blue line is the external dry bulb temperature. You can see that just using a mechanical fan constantly, the internal temperatures track external quite closely, and there's potential overheating and overcooling, whereas the evaporative system manages to maintain a smaller band of temperatures, and you can see the benefit of the evaporative process when external temperatures are higher. To conclude, I believe that this application is quite unique because it combines different assessment methods and plant simulation tools. The detailed HVAC application is more often used as a design tool rather than for thermal comfort analysis, and so I believe that this application helps to democratize the use of such tools. And the scripting and programming is emerging within dynamic simulation software at the moment, and in this case it demonstrated that the controls are effective, and this design can be rolled out at future phases within the scheme. And then comparing real data to simulation has helped to validate the model and give us confidence that this assessment method can be used in the future. And all in all, building performance simulation should promote energy efficient and environmental friendly technologies such as this one wherever it's appropriate. Thank you.
Excellent. Thank you, Vasiliki. Right on time as well. Any questions from the judges?
I had a question about the use of the EMS and the HVAC tool. Before then, what workarounds would you use to do work like this?
Evaporative cooling cannot be simulated otherwise, so it was a first for us. And, yeah.
Thank you.